we're going to find the volume of the solid form by revolving the region bounded by the graph of f of x is equal to the square root of the sine of x. So I'm giving you a really tough function here, a square root of a trig function. But sines are easy to deal with. And the x-axis between 0 and pi. So these are actually going to not be too bad for it because we're going between 0 and pi. About, whenever you see the word about, that's what we're going to rotate around. That's what it means, rotate around the x-axis. First thing we have to do is graph the base of the region. It does not have to be a 100% accurate graph. It just needs to be a graph that we can use as a basis to draw a rectangle. That's what we want to get out of this. The whole thing hinges on being able to draw the representative rectangle. So if we were able to draw the rectangle, then we're in business. So we need a graph that's going to show us enough. And the graph is going to go from 0 to pi. So I'm going to go 0, I'm going to go pi over 2, and then I'm going to go to pi. Now it says f of x is equal to square root of the sine of x. I want f of 0. So I want the sine of 0. Think of the unit circle. What's the sine value of the first point on the unit circle at 0? The first point is 0, 1. So what's the sine value? 0. What's the square root of 0? 0. Now, find out what f of pi over 2 is. And why did I choose pi over 2? It's our 90-degree angle. It's a quadrantal angle. Those are either going to be, these values that I'm looking at are zeros or ones. For sines and cosines, the 0, pi over 2, and pi's are 90s and are 1 or 0. Now, I need the square root of the sine of pi over 2. Now, if we think of pi over 2, it's the 90-degree angle. The sine goes from 0 to what value? 1. So it's the square root of 1, which is 1. So I can put that point up here. And now I want the function evaluated at pi, so I want the square root of the sine of pi, which is another 0. So without a calculator, we're able to get, that's good enough. It looks like basically one lobe of the sine function, but it's a square root of all of them, so it's changed them. Now, draw your rectangle. There's your representative rectangle. I want that r of x. Now, are we on the axis or off the axis? We're on the axis. So do we have to worry too much about anything else outside of just the distance between here and here? Well, that value is 0. This value is a square root of the sine of x. So what's r of x? Yeah, it's the square root of the sine of x minus 0, which is the square root of the sine of x. What would be r squared? If I took that function and I squared it, what would be r squared of x? Sine of x. So sometimes it's easier to just figure out, all right, what's my r of x? And then after I figure out my r of x, square it, because I'm going to have to square it. And now I have the sine of x. And now I have to use my formula. Since this is the disk, I need the disk formula. The disk formula, this guy right here, is r squared of x, because it's pi r squared, so it's pi times r squared. Now, what's the lower bound? 0. What's my upper bound? We're going to pi, because we're going from 0 to pi. Now, my big question is, all right, well, what's the... I know this is going to be pi. What's the integral of sine? Cosine. Is it cosine? It's negative cosine of x from 0 to pi. Because remember, what this is going to end up being that disk, so we have to take the area of the circle, which is pi r squared. So I just put the pi out front. So remember, it's pi times r squared. That pi goes out front, the r squared goes in there. Now, what's pi? Or what's, for the cosine is negative 1, so I'm going to get pi times the opposite of negative 1 minus, now what's the cosine of 0? 1. But I want the opposite of 1, which is going to be negative 1. Do you think we have enough negative signs going on in here? Now, I want the opposite of negative 1 is what? Positive 1. And then I'm going to subtract the negative 1, which makes it positive 1. So we get pi times 2, which is 2 pi. That's the area, or that's the volume of my shape. That's it. We're done. Now, we're not done, but we're done with this problem. Now, does this make sense, how we figured out the graph? We figured out the graph, we drew the rectangle, we figured out what the length of the side of the rectangle was, and it was just pi, or the square root of s, or sine squared. We squared it, and we got r squared was sine of x. We used the disk formula, which was right here, and we ended up with our volume. That's pretty much everything that's going to happen. The only other, the time that it might get a little bit trickier is where, like for this guy right here, where you have here is a little bit different. You have find the volume of the solid formed by revolving the region bounded by 2 minus x squared, and g of x equals 1. About the line y equals 1. And This is actually shown in a picture. I don't want to give away the answer, so I got to fold up this. And where's my tape? Brought my tape out, but no, I don't know where it is. All right, we're not going to worry too much about that. All right, here's the diagram. Here's f of x, and here is g of x, and now we have our rectangle. Now, what's the height of the rectangle? How am I going to figure out the height of the rectangle? If I want to figure out what my r is, how do I figure out the length of any segment like this? We did this before. Yeah, we subtract them. It's top minus bottom. So in this case, it's going to be f of x minus g of x, and that's equal to r of x. So this is going to be 2 minus x squared minus what g of x was. What was g of x? 1. So this is 1 minus x squared, and that's my r of x. Now, once we figure that out, what's r squared of x? So we can use our formula that's a minus b quantity squared is a squared minus 2ab plus b squared. So what's my a squared? What's 1 squared? 1. Minus 2 times 1 times x squared, so it's 2x squared, plus, what's x squared squared? X to the 4th. Now, where do the graphs f and x, or f and g, intersect? What are my bounds? -1 and 1. So my volume is equal to pi times, from -1 to 1, the integral of 1 minus 2x squared plus 4x, or x to the 4th dx. Which is what we ended up getting here. Now I'll just show you what the answer ends up being. Now the biggest thing that we end up dealing with is, one, is finding out where the two graphs intersect. Now, granted, it was nice that they gave it to us, but if we have to figure that out on our own, how do we figure out where two graphs intersect? Set them equal to each other. We want f of x equal to g of x. So we want 2 minus x squared is equal to 1. Move that, subtract the 1, subtract the x squared, you get x squared is equal to 1, so this one was easy. Plus or minus 1. So this one actually was pretty simple, as finding out what those values are. That's how we get the -1 and the 1 in the picture here. We set the graphs equal to each other, and then we were able to figure that out. And then we have to integrate between those. We figured out what that length of the r was. It was just the top minus the bottom, which is what it's going to always be. Top minus bottom. And then you integrate it, and there's some math that goes into that. You get 16 pi over 5. there's the whole worked out problem. And you can pause the tape and look at it as you at your leisure. Let's